Okay, welcome back, everyone. We have 3 more talks in the rest of this aquatic sciences section. And then in 1 hour after those talks, we have a 25-minute aquatic sciences facilitated discussion. So I hope you'll stick with us through all the way through the end of that discussion. Right now, we have Jenna Robinson and Maartje Korver. Jenna's with the Rensselaer Polytechnic Institute and Maartje's with McGill University. And they're speaking about Lake Expedition 2020, a virtual collaboration of early career researchers integrating machine learning and aquatic sciences. Take it away.
Thank you, Allison. I'll share the screen. All right. There we go. Thank you, everyone, for being here. My name is Maartje Korver, and so today I will, together with Jenna Robinson, talk on behalf of the Lake Expedition Research Group about our collaborative research. We are a group of mostly early career researchers from across the world, and we have been coming together virtually for about a year now to work on an interdisciplinary project that integrates the aquatic and computer sciences through knowledge-guided machine learning. In this talk, however, we will not focus on the research details, but talk about an important aspect of interdisciplinary and collaborative research. And that is the science of team science, which is here illustrated as the boat that keeps the team together during research. So in the spirit of team science, this talk will also be collaborative. So I will first introduce the team, our objectives, and the importance of team science, and then I will hand it over to Jenna.
Hi, everyone. I'm Jenna Robinson. Like Maartje mentioned, I'm also part of the Lake Expedition Group. And after Maartje introduces our team and objectives, I'll jump in and discuss good management practices for research teams. I will reflect on what our team has learned so far, and hopefully I can engage you in a discussion with a poll on Slido about your own experiences in research teams based on what Maartje and I have talked to you about. And with that, I'll hand it back to Maartje.
All right, great. So the Lake Expedition Program is established by the Global Lake Ecological Network, or GLEON in short, and it receives support from the National Science Foundation. It's a team science program for graduate students, which means that we learn about effective collaboration practices in a large, diverse and international team of researchers. And we all have different backgrounds and various expertise. So this program is really in line with some of the core values of GLEON, evolving around interdisciplinarity, collegiality, collaboration, inclusion and diversity, and to share ideas, expertise, and data. So why are we doing this? On this slide, you see a figure from an article by Vukti, Jones, and Uzi, who showed that science and the generation of knowledge is more and more performed in teams, rather than traditionally by one solo author. So both the number of publications with team authorship and the size of these teams have been growing in the sciences. And it's also been shown that outcomes generated by teams surpass individual accomplishments. So team science is really the future. But at the same time, there's very little training in our education system on how to effectively work in teams, especially when these teams consist of members with different backgrounds and expertise. The way that our training program is set up is that we first actively learn about team management and collaborative skills through workshops. And then we apply this knowledge in practice by collaborating on a research project for which we develop the necessary technical skills. And we also create products in the form of publications and outreach events like presentations. And so the main technical skill that we are learning, the main skills that we are learning are all centered around machine learning. So this training program has been in place since 2012, and so far 3 cohorts of students have completed it, each of them focusing on different research topics that were all of their own choice. And this has resulted in several publications and products on topics ranging from how to do team science, to water quality modeling or developing ecological apps. So this is the current cohort that started about a year ago. So what I want to highlight is that we are a highly diverse team, connected through a law for the aquatic sciences, that is. But what I mean by a diverse team is not just in the sense of identity, like gender or ethnicity, but also through a mix of career stages, expertise, and backgrounds. For example, we have both early career and experienced researchers. We have people with a background in ecology, hydrology, computer, and also social science. People that do field-based research and modelers. And researchers that work from like local to global skills. So this diversity means that we all bring our unique views and philosophies to the group. And that's illustrated here by all the different ways that you could perceive this symbol. Like you could see it as an 8 or an infinity symbol or a molecule, etc. So team diversity is really key to booking positive research outcomes. Here I show a diagram from an article by Chiravelli and others that showed really nicely how in a setting of ecological collaboration, how team member diversity has a direct effect on overall team functioning and communication, and how that is in turn very important to book positive research outcomes. So the goal of our research project is to assess patterns of change in lake and reservoir area of about 100,000 water bodies in the US. So this is a research objective that we developed ourselves through a few brainstorming sessions, but partly driven by a shared wish of the group to learn about machine learning technologies. The aim is to build a machine learning model that can, on the one hand, fill time series data gaps, and on the other hand, identify clusters of lakes that share similar patterns of aerial change over time. So here you see a first preliminary result of one of our model runs. But for specifics on this project, I would like to invite you to check out the poster that we created for this conference. And it's being presented by our cohort member, Heather Wander. So to close off my introduction, I would just like to add that the theme of this conference, knowledge-guided machine learning, lends itself specifically well for team science, as it consists for the first part of knowledge-guided, which in our group represents the limnologists, the hydrologists, the ecologists, and for the second part of machine learning, which represents the people with technical skills and experience in more computer sciences. So there's a constant interaction between like the domain knowledge that informs the technical machine learning models. To give a really simple example, like our data analysis informed us that the data gaps of our data set were centered in the north of the US and mainly during wintertime. And then our domain knowledge explained this by winter lake ice cover. And then on its turn, we can use this to inform the machine learning model when it will fill in the data gaps. So but the real topic and the question of this presentation is, how do we make sure that this part, so the communication and the collaboration, between these two groups is effective and also pleasant. So I'll hand over the stage to Jenna to dive into this and tell us about good management practices of teams.
Thank you, Maartje. Yeah, we can go to the next slide. So like Maartje mentioned, about 1 year ago, our team came together and met for the very first time. And many times when a research team is forming, you tend to focus on the technical skills that each individual can contribute to the group. But focusing on team relationships and communication early on is crucial for maintaining good team management practices. When we first met, with training from the great community sociologist Jenny Cross, our team prioritized and learned how to build relationships, communicate with each other, and how to set up a framework that has allowed our team to share leadership roles and evolve through time. But transdisciplinary science does require more than just interpersonal skills. Let me go to the next slide. A good team also needs balance in the technical domain. If you've ever worked in a team and felt frustrated or confused about the details of the project or your role in the group, it's likely that your team is out of balance and this web of technical and interpersonal skills might be a little bit out of whack. And like any machine learning problem, if you're not getting the results you need, you have to change your inputs to your model. And our group realized that we needed additional skill sets to answer the research questions that we had designed. So we brought in new team members to our collaboration and brought back this balance that we needed to maintain efficiency in our research. A paper published this year focusing on macrosystem science specified that interdisciplinary teams require a distinct set of skills to carry out successful group projects. This includes systems thinkers. Every team should have at least one of these systems thinkers. They're the type of person that can evaluate interactions and relationships within the team. You also need to have good skilled communicators who can communicate with understanding and clarity to the team and to members outside of the team. And you also need to have domain experts that have deep knowledge and expertise within the field. And among these and a few other skill sets, these types of participants have been shown to be crucial for not only project efficiency, but also for improving career readiness and high impact science. However, with all these skill sets in one group, you inherently have a lot of diversity on your team, which can also bring some challenges. And in order to benefit from this diversity and utilize the creative opportunities that can come with it, it's helpful to understand the conditions for creativity and therefore the high impact science that it can bring. So when your team first sits down and starts to plan out a research project, you may fall into this realm of divergent thinking. You have many ideas that you can focus your research project on. What's new, what's novel, what research questions do you want to answer? This step is necessary in the early stages of a project and ultimately leads to innovation, but good communication can be hard if one team member wants to go one direction while you want to go another. And eventually you do want to transition into this realm of convergent thinking. What are the specific questions you want to answer or the hypotheses that you want to test? This is a comfortable place to be in when you find the direction you want to take your project. But getting to this point, it can be tricky. There's no clear path between innovative divergent thinking, and ultimately getting to that decision point and converging in on a single idea. And this area in between these two realms has been coined the groan zone. And our team has felt the full force of this zone numerous times. And I'm sure that many of you can relate to this. But acknowledging the fact that the groan zone is part of the creative process allows you to tap into the skills necessary to make your way through it. When you're in the groan zone, you may feel like you're not moving forward, that you might have an uneven distribution of tasks. And in today's world, that meeting virtually might make it difficult to stay engaged and efficient. But through the awareness of the groan zone, you can create the space necessary to plan and evolve. You might have to generate action plans and set expectations that can be changed through time. You may decide to facilitate and delegate tasks, to listen to each other, and to reflect on your experiences. Our team found that actually putting an abstract together for this conference helped us move through the grown zone. And in addition to this, we also, leading up to this conference, we decided to do a team reflection where we anonymously thought about the things that we are good at and the things that we need to work on so far over the course of the year that we've been together. And we found that our team has really great cohesion. We have good team evolution, enthusiasm, communication, respect for each other, and a feeling of responsibility for our team. But we also learned that we need to work on balancing our other priorities with this research project, that we need to delegate tasks and clarify expectations to move through the grown zone, and that we need to work on maintaining individual involvement. And through this reflective process that we went through, we learned that you need to balance teamwork and task work to maintain team efficiency. And through this reflection, we created the space necessary to address this imbalance and move forward and get through that grown zone. And so after talking about all of this, I want to ask you all a question. I'm sure there are many experts in the audience here, both in machine learning and beyond. And I want to ask you, have you ever been a part of a research team as an expert in your field? And if so, based on what Maartje and I have talked about, what have your teams done well with, and what do you wish could be improved upon? I put a poll in Slido, and it's just multiple choice. And I was wondering if you would be willing to go in and select the qualities that you feel your research teams have done well with, and then don't select the qualities that you feel like you may have needed to work on in your team. And then if we have some time, we can discuss this at the end or in the discussion in a little while. And yes, thank you, everybody.
That's fun doing that poll. I'm really looking forward to seeing what people come up with. I guess while we're waiting for that, can I ask a question? Let's see. So a critical question for a few students in the audience could be, when is the next cohort and how can students join?
That's a great question. I think there's usually a few years in between each cohort. I'm not sure if this depends on funding or Paul and Kathy's availability. But if you go to the GLEON website, gleon.org, you can find information about how to apply to the fellowship.
Thanks. One other question. Are there any issues in working on a long-term project with people you've never met in person?
Yeah, I think that with any project, when you are first meeting people, you might be hesitant to fully engage, or might not be aware of everyone's skill sets. And I think that's really why it's so important to build these relationships early on, so that you can move through that phase and get to know each other better.
Maybe I'll just add one thing to that. So it was all virtual, and it's definitely a challenge, but we did do an effort, even though it was virtual, to do some like socializing activities, and they actually really helped. And that's something I would really recommend to any group that starts out like that. It might feel a bit awkward in the beginning, but it will pay out, even if it's virtual.